React. How are we doing today? My name is Ruslan. I'm an engineer on the React team at Meta, and I'm super excited to be here today to tell you about the React performance tracks, the feature that we've just shipped in the latest release of React. So my goal for the next 20 minutes is to explain how you could use it to understand how React works under the hood and how you can leverage it as a tool for debugging and profiling your React applications. And we're going to be doing the live demo. So you should see my app here that I've created for the purpose of the live demo. It's a simple like e-commerce app where you can add an item to the cart. Here, for example, it will show the checkout, like the cart, and then you can click the checkout button to show it will show the checkout form. So on the left column here, I have the code execution panel, which shows what was happening in real time in React and JavaScript. So for example, here, when we were handling the hover event, we were updating the state. So let's start again. So when I hover my mouse over the Add to Cart button, we can see here on the left that state update happened. When I click, there are multiple events happening at the same time. Let's take a look at each one of them. So when I clicked on the button, you can see that we updated the loading state, and we started rendering the loading state of the button. Then we started a transition that kicked off an asynchronous action that sent the request to the server. Then once the request is finished, we started a new transition to update the state, which opens the cart component on the right here. And at the same time, we started rendering the footer fallback. So we displayed this fallback while we're fetching the information about the discounts and total price of the items in your cart. Once the network request is finished, we display the actual content of the suspense boundary, and then we actually start pre-rendering the checkout form in the background with the newest API called Activity. And in the end, when the user clicks the checkout button, this form will be displayed. So that was a kind of crash course into how my app works. But would it be nice to have such tool that we can see here on the left, like this time travel debugger, in your browser DevTools? Well, turns out with performance tracks, it's no longer a theory. You can actually have all of this in your performance panel. So let's record a trace with the performance panel and see what it can offer. So when I open my Chrome DevTools, I can start recording a trace. I will do the same steps, add to the cart, wait until the server request is finished, click the checkout button, and stop the trace. So I'm going to hide a bunch of unnecessary things here. And then move to the left and zoom in a bit. So what you will see and what we call React performance tracks are these custom tracks that are prefixed with the item Unicode symbol. Let's discuss each one of them separately. So scheduler is an internal concept of React that was introduced with concurrent rendering. Think of it as like a work orchestrator that has a work of different priorities, but it can only work at one task at a time. All these priorities are actually listed here as a subtracks under a scheduler. So you can see blocking, transition, suspense, and idle. Let's discuss each one of them. Blocking is a default priority that runs any synchronous work. So for example, if you need to synchronously update the UI when the user clicks on a button, you need to instantly show the loading state of your button. Transition is basically any background work that happens under the hood and does not kind of stop the browser from painting. For example, this happened here when we clicked off transition to update the visibility of the cart component. Next, suspense. So suspense kind of is a unique priority for any suspense-related work, like revealing the actual content of the suspense boundary. And lastly, idle. Idle is the work of the lowest priority. Basically, it will only execute if there are no other work scheduled with a higher priority. And it's actually used in the newest feature in React called Activity. So all these priorities and subtracks are actually ordered in a way of the way the schedule will actually execute them. Whatever is on top will be executed first. So yeah, that's it. Now, let's take a look at the other track called components. So components is a bit more intuitive track that can display you the component renders and effects and their corresponding durations in a flame graph order. You might have seen something similar in React DevTools Profiler panel. Okay, now let's actually take a look at what these tracks show. Let's try to see where this interaction is on the timeline, the handle of the onClick event. Actually, no, let's start with the hover event. So the first thing that I'm seeing on this timeline is this, on the blocking track, is this event. So when the browser registered this event on a mouse move, we actually were going to display all of it on a scheduled track with a corresponding priority, because this was happened with a blocking priority. Now, you can ask, like, how do I know if this was actually this update that was caused by this set state? So when you click on an update entry or any entry on this set of blocks here, the bottom panel will actually show you all the metadata about the actual update that happened in React. You can see things like the component name that actually scheduled an update. You can see the name of the method. It could be like setState or like dispatch. But also, you can see the full stack trace in development mode, which can help you explain what actually scheduled an update and what caused it. So if I, for example, click on the handle mouse enter, I can see that here the set hover was called. And if I go to the performance panel and use my custom use is hovered hook, I can see that the set state was called here. So now, how can I understand what actually was re-rendered because of this update? So both scheduler and component tracks are aligned vertically on a timeline. So if you zoom in a bit, you will see the render entry here. Everything that's under the render entry on a components track is actually the subtree that was re-rendered because of this update. So for example, the add to cart button was re-rendered and the hovered cart item was mounted. So this yellow entry that you see here, you can think of it as like a UI indicator of whatever is below it actually was mounted. So like the subtree below this mount entry, it was actually mounted. This is what we did to show the new icon when we hovered the button. All right, let's continue. So once we click on the button, we actually do a lot of steps here that I was showing you. So let's find these events. So one of the cool things that I love about performance tracks is that there are multiple data sources on the same timeline. I don't need to just look at my React performance tracks. I can also use built-in tracks from Chrome. So I can find where the click event was actually handled, and it happened here. I can see the pointer event here, and if I zoom in to this point, I can see where exactly the pointer event was happening and when it was handled. And now this is interesting. So we see two entries on different tracks here, both on blocking and transition. So basically the same event caused the work of different priorities. So let's try to understand what happened. So once again, I click on the update entry, and I can see the name of the component and the set state and the stack trace. And if I jump to my custom hook here again, I can see that there was another set state that updated my state of the component and switched it to true. So I started rendering the loading state of the button. Now, on the transition track, I can see that some action was kicked off. Again, if I look at the stack trace, I can understand where exactly it happened. So let's start from the bottom. It was kicked off here in the start transition. That kicked off this asynchronous action on line 31. And then in the end, it was scheduled this update to update the visibility of the cart component. Okay, so one thing to notice is that at the same time, we rendered some components here at cart button, for example. And we kicked off a network request to actually add this item and synchronize the state with the server. Because I have the network track on the same timeline with my React performance tracks, I can actually just scroll to the point of time where this network request has finished and see what will happen next. So if I take a look, so there was multiple events scheduled again, both on blocking and transition. And we can take a look at same at this update entry and see what happened, what caused it. So when we finished the network request, we actually updated the local state of the component with the new with the item that was added to the cart. Okay, so at the same time, we actually rendered the cart component, and here we also another thing, like let's take a look at the render entry here. So you can also understand which subtrees were rendered with which priority. So for example, aligning with this render entry on a blocking timeline actually tells me that this subtree was re-rendered with a synchronous priority. While at this point of time, the new render of the app component and the corresponding subtree happened in a transition. What I also like about React performance tracks is that they can show you additional information about your app and why some things are rendered. So for example, if I click on this cart component on the components track, I can see which props changed to understand what caused the re-render. Now, I can see that there's a new component that was mounted, cart footer callback. And it kind of like correlates with the network request that happened again in the background. So that's where we were rendering our fallback for the suspense boundary and where we actually kicked off network requests to fetch the total cart value and possible discounts. So let's just jump straight to the point of time where this request was finished and see what happened next. You can see that the network request finished here, and there's some work that happened on the suspense subtrack. Okay, so something's rendered. And I can see that the cart footer and some like subcomponents of the children components of this has rendered. But there's this strange like reconnect entry on a timeline. So basically, you can think of reconnect as something as a mount for something that was pre-rendered in the background. You can see it, for example, for activity components or your suspense boundaries. Now, as I've previously mentioned, my app is structured in a way that when the checkout button is rendered, I start to pre-render the checkout form with the new activity API. So you can actually see it on the idle track. There's this green bar called prepared that actually shows what was actually being rendered in the background. And we can see that the checkout form was being pre-rendered. You might have noticed this red entry on a timeline called cascading update. So what is this? So cascading updates is usually a symptom of performance bottlenecks and unnecessary re-renders. It could be described as like an update that was running during the previous render or effect while React was performing all the work. So React has to throw out the previous update and start new one again. Actually, with performance tracks, we can just now see what caused these cascading updates. So I can jump to I can see that this happened in my cart footer effect here in the handle footer ready callback, which scheduled like a set state again. So this is how you can also use React performance tracks to find all these performance bottlenecks and the necessary re-renders and updates. And it was never easier than today with React performance tracks to find these. All right, now back to some slides. Sorry. So we also have server tracks, which are like server component tracks and server requests that I did not cover as part of my live demo. These could be really useful if you're using server components. You can learn more about them on docs at react.dev. These are really great. So going next, It was a really kind of long and bumpy ride. And I wanted to give a shout out to Chrome DevTools team for all the amazing work and collaboration on the performance accessibility APIs. Without these APIs being supported in Chrome, none of it would be possible. So like, round of applause for the Chrome team. We really hope that other browsers are going to implement these APIs as well and collaborate on the standardization of them. So how can you use it today? So as I said, it's enabled in 19.2. You don't need to do anything if you just want to use them in development builds. They are enabled by default. For profiling builds, performance tracks will be enabled for the subtrees that are wrapped in a profiler component of React, or for the whole app if you have React DevTools browser extension attached. So now another point worth mentioning is that we are actually not removing the panel, profiler panel in React DevTools, but we are replacing the timeline feature of it with the React performance tracks. Profiler panel of React DevTools still offers a lot of useful information about React. So yeah. Now, speaking of DevTools, there's another thing that I wanted to mention while I'm on the stage. We are actively working on a new panel that will be called Suspense, which will offer advanced debugging capabilities of debugging suspense boundaries of your React applications. And I have a quick demo that I wanted to show you what soon will be possible with it. So on this demo here, I have a suspense panel opened where I can see all the suspense boundaries visualized in the UI. We're also going to be showing the reasons why a specific suspense boundary has suspended. It could be like a network request, like a promise, or it could be like a React.lazy wrapper. Another feature that Suspense panel can offer is the timeline of the suspense reveal order. So on the bottom here, you can see that I can switch between different timestamps in my between different time points on a timeline, and I can see how my app looked like at a specific point of time. Or I could use the replay button to just reveal the contents of my app in a document order and see how it looked like at any point of time. So all these features that I mentioned today related to React DevTools, some of them are already available in React DevTools 7 that we've just published in the Chrome stores. We're actively working on the suspense panel, and we're planning to release it later this year, so stay tuned. And that's all I had for my talk today. Thank you so much.